Here we go for part 2, and where we are is part 2. So let's get at it. Using algebra to solve a rational equation or inequality. It says use algebra to solve this. And we did this last day, so it shouldn't be too surprising. Check your solution from part 1. That's when we solved it using a graph. Um, how do we do this? Well, hint, we can cross multiply as long as we're not multiplying by 0, right? We can't multiply by 0. X can't be 3 and X can't be -1, in which case these graphs would have been undefined. These expressions would be undefined there. Dandy. So what I can do is I'm going to cross multiply. Basically, multiply this up here, multiply this up here. The idea is multiplying by the smallest thing that will divide, uh, that each of the denominators will divide into, and then we cancel. And this is essentially the same thing. So what do we got? We have this polynomial equation, which is actually quadratic, isn't it? It's not that bad at all. It's a grade 10 one. Add to both sides, get one side equal to 0, and if we have to, we'll use the factor theorem. If we had to, we could use the quadratic equation, but this one factors. And I get the solutions, -3 and 1. Well, let's have a look. Check your solution from the part 1. What were my solutions? There they are. -3 and 1. What were my solutions? -3 and 1. Dandy. Let's keep going. This is nothing new because we did this last day. I'll use algebra to solve this inequality. See, this is new. Hint. We solved polynomial inequalities by solving the related polynomial equations. So what we did, remember, when it was two polynomials have a less than or greater than sign between them, is that we made it an equal sign and then used test points. Then we graphed solutions on a number line and used test points to determine which regions satisfied the inequality. Not so fast. These graphs are more complicated. Peek back at your graphical solution. How could the vertical asymptotes get involved in your test point solution? So let's look back at when we solve this graphically. Notice that here it is. No, it's not. Where is it? Here it is. Okay, so we were solving this graphically, and the idea is we were looking at where one graph was bigger than another graph, or less than another graph, and of course the equal points, where they were equal, were cutoffs, but also we had asymptotes as cutoff points, right? Solution, 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 solutions. All of a sudden, on the other side of the asymptote, no solutions. So that means we should probably add any undefined points, any vertical asymptotes to our list of points of solutions. So, and that's what it talks about here in the not so fast. Moral of the hints when solving rational inequalities. So we can solve the related equation, plotting solution points on a number line. Those will all be cutoff points from regions of solutions to non-solutions. Then it says plot restricted x values, vertical asymptotes for the related functions on the number line as well. And then use test points to determine the regions that satisfy the inequality and write your answer in set notation. Hint. Now, just kidding. We should actually be able to do this now. So what we're going to do is we're just going to sort of follow this procedure, solve the related equation. That's going to be the first step, solve the related equation. And of course, in solving this related equation, we also see the restricted values. We can cross multiply here as long as x is not equal to -3 and x is not equal to +3 and -1. So that means these points have to go on our number line, right? And I'm going to cross multiply, and I get the same. I'll get the same cutoff points, right? -x plus 3. I get the same cutoff points as I had before. This is not surprising. I get x. Might as well make it look real nice here. plus 3, x minus 1 equals 0. So what do? And notice that it's just a coincidence that they're the same numbers as our restrictions, opposite signs. That is a coincidence. Don't read anything into that. All right, so we solved the related equation and plotting the solution points on a number line. All right, number line, number line, number line, number line. So we got -3. We got 1. Plot restricted x values. So there are my restricted x values. There's 3 and -1. And again, just a coincidence. And notice that all of these, because it's a less than, are all, and in fact, I'm going to do something to remind me that these were the restricted values. I'm just going to write down a u on top of it so I know that the function is undefined there, or the equation is undefined there. And now I have a bunch of test values, 1, 2, 3, 4, 5 regions to test. And of course, if we were working in class, we'd split this up and each of us would do a little bit. So, but I'll show you what I mean about checking test points here. So for instance, if I want to test this region, I just pick a point to represent this region. So for instance, x equals -4. And I'd compare the left side to the right side of the inequality. So the left side is x over x minus 3. The right side is -1 over x plus 1. And then I substitute in -4. -4, -4, -3. -4 over -7 is 4/7. And over here, I get -1 over -4 plus 1 is 1/3. Okay, is this true? Is the left side less than the right side? Well, they're fractions. How am I supposed to know which is bigger? Well, hopefully you can see that this is indeed not true. 1/3 is less than 4/7. But if you're not sure, remember, you can always change those to decimals. Fire that into a calculator, 4 divided by 7, get a decimal value. This one's 0.3333333, and then you can compare them that way. But either way, you get that this is not a solution, right? And so it means all the values in this region are not solutions. And I'd continue like this. Now, again, in class, we'd split up this work. You don't have to sit there and watch me put all these test points in. I'll give you the answer that this is a region of solutions. So what would be a test point? Maybe you'd try x equals -2 in here, because that's a value, and it works. So the left side is less than the right side. In here, my favorite test point, which is x equals 0, not a solution. So that means this is not a region of solutions. Similarly here, it is. And this is a common thing. It doesn't always work like this, where I go from region of solutions to non-solutions. You do have to check them all. X equals 2 would be, and over here x equals 4 would be a nice point to check, or 5. And then I get my solution set from there. And notice this also matches what we had before. -3 is less than x is less than -1. So, well, wasn't there an easy way to do this before when we were doing polynomial equations? We just sort of did a graph and we could see where it was bigger than 0 or less than 0. Well, we did, except for these graphs are way more complicated, and good luck trying to find where these graphs cross and go up and down and stuff like that. If we're doing this algebraically for rational functions, unfortunately, we have to check the test points. And that's nice to work with a neighbor and have that help you out. Now, if you were allowed to use a graphing calculator and you could see where one was bigger than the other, where the left side was greater than the right side or less than the right side or whatever, then that's fine. Okay, so there we go. Let's keep going. Example 4, and again, you're going to have to do this on a separate piece of paper, not enough room. Use algebra to solve this equation. Now, since it's an equation, I can just cross multiply, right? As long as x squared minus 2x, as long as that bottom's not equal to 0, then I can just cross multiply. -4x equals x squared And we solved this one before, right? Using a graph. Where was the graph? It was this one, right? And we estimated, and we were sad about estimating. Now we're actually going to solve this, which I think we did a little bit of this yesterday as well. But I want one side equal to 0, so I'm going to add 4x to both sides. Add 4x, and then can I factor this? I should be able to factor it. And I get, oops, this answer and this answer. And notice that this is way more accurate than my solution before, right? I was guessing from my graph. I didn't know how slanty my graph should be. And so I guessed at -6 and 1. But could I convince you that that should be at -4 and 2? Yeah, if it's a little more slanty, you could probably be convinced that those are the right solutions. Well, let's keep going. Use algebra to solve that inequality. So what are the steps? Well, the first one is to solve the related equation. Right? Solve the related equation is 4x over x squared. Well, this we've done, right? Solve this related equation. We did this one quite a bit to find x-intercepts. As long as x squared minus 2x minus 8 is not equal to 0, then we can do that, and I get a single answer, x equals 0. Well, what do the hints from earlier say? They say, well, write that on a number line, but also write your restricted values. So the restricted values are where the vertical asymptotes of the graph would be, and we did this earlier, but factor that, find out when this is actually equal to 0, and I do have problems. X equals 4 and x equals -2. X equals 4, x equals -2, and then I get 4 regions to check points to see whether the left side's greater than, or sorry, left side's less than the right side or not. And again, here it's undefined, so obviously that's not a solution. Call that undefined. This is undefined, that's a solution. And where it's equal to 0 isn't going to be a solution either, because this is a less than. If this was a less than or equal to, I'd color in that dot, but this isn't a solution, and now I have 4 regions to test. So test point, let's try this one right here. Let's try x equals -3. And notice, I like using, especially when I'm comparing to 0, I like using the factored version. And same as the textbook likes using the factored version, and you can check out the textbook's way to solve these are significantly different than mine. But for -3, notice -4 times -3 that's going to be a positive, and I don't care what, and I'll show you why in a second. That's going to be a minus, right? -3 minus 4. And I could get the exact value, but I'll show you that I don't really care. And that's a positive. Why is it okay just to use positives and negatives? Well, I'm comparing to 0 in this case. So the other ones, I was comparing the left side to the right side. But when I'm comparing to 0, all I really care about is whether it's positive or negative, right? So is the left side less than the right side here? No, because the left side is positive. So this is not true, and this is not a solution. Similarly, I can continue on finding these test points. By the way, you don't have to do it this way. If you don't like this positives and negatives business, you can just clunk it into a calculator. It might take you a little bit longer, but if it makes you feel better because you know what the numbers actually are, then you go ahead and you do it that way. Okay. And I'm just going to, that's not solution there. We do have solutions here, and no solutions there, and solutions there, and we get the same solution set as we had before. -2 is less than, x is less than 0, and x is greater than 4. Okay? Dandy. I wanted to make a point before we shoved off there. Okay, and don't be afraid to use a graphing calculator to check these. That's fine as well. Okay, there's a few from the homework. Last day there was a bunch of equations, and then we're continuing working on the same stuff, and the new stuff is the inequality, solving rational inequalities. All right, that's it.